about the data first. So here's the problem. When you talk about AI initiatives, when you talk about businesses making decisions, there's a problem. And the problem is the amount of available data today. So today, businesses are analog, they're manual. There may be some partially connected areas that the data is just not being utilized anywhere, but only about 25% of a manufacturing floor or an airline operation, an MRO facility, in the enterprise in general, only about 25% of that area is connected and generating real-time data today. And so at Thinaer, we have always had this philosophy that data is gold. And now we're bringing people the ability to make better AI decisions, make better decisions by humans today. We were very lucky 5 years ago to run into a forward-thinking company, Lockheed Martin, and some brilliant people at Lockheed Martin, Gregg being one of them. And we actually...
Checks in the mail.
So we actually stole this data as a service saying from Gregg. Think about that 25%. So businesses are making decisions with 25% of the data.
So those of you that are aware, Lockheed Martin, we build a lot of very high-tech, very one-off type products. And the machining that's involved in doing these things, most of it's not connected. Most of it I have no visibility into the data. Most of it I don't have a way to understand where I am in my manufacturing process. So we spent a good amount of time trying to figure out how we get data, make visibility of data, not just to my manufacturing operations folks, but how do I let supply chain know? How do I let manufacturing operations, how do I let finance know where I am in the build? All this other kind of stuff. And that drove us to a data as a service mentality. We stood up something called our Intelligent Factory Framework that gave us a network fabric that enabled us to connect our factories and feel comfortable and safe with the things that we do and the things that we build, especially the sensitivity around the data. The challenge became, in talking to Bryan early on, you know, I had been the IoT architect for Lockheed Martin and RFID architect for 10 years. And we could do stuff with passive RFID and all other things, and we played with RTLS. But how do we take it to the next level? The data is the key, and I'll challenge Bryan. Data is no longer the new oil, data is plutonium. And when we talked to the CIO of Space Force, the CDAO of Space Force last year at the Fellows Conference, he challenged us to understand data better. And, you know, most people say garbage in, garbage out, good data makes good decisions. I challenge you to think about all data makes good decisions. In this world where we're building machine learning models and information about our product, a huge portion of machine learning is all about building simulated data that takes me beyond what I know is good. So one of the challenges we have is we're collecting these million data points with Bryan's technology in our factories, and how do I understand that data to understand whether it's good data, bad data, or indifferent data, collecting it all, having the capability to build these data models that lets me make decisions and not have to simulate a ton of data, a ton of information, and then give my factory and my people in my factories the ability to make decisions.
So, Internet of Things, we were keeping track of things. But then the same infrastructure, and this was part of our original discussion and Gregg's vision, let's use that same infrastructure to understand the health and the utilization of the machines along the manufacturing line. And so we started with that, and lo and behold, we put sensor, vibration, and temperature sensors on a few machines. We're to the point now, one machine has 32 sensors on it.
Yeah.
So we're tracking anything and everything and creating a real-time digital twin of some of the machines. So now we're talking about the pedigree of that part. We're talking about the raw materials all the way along the manufacturing process, the health of each machine along the manufacturing process, the environmentals that it's experiencing all along the manufacturing process. So this is a very different approach. We stepped well beyond RTLS, even beyond IoT, and it's turned into a very exciting initiative. So where we've gone today, we've mentioned a couple of times, millions of data points every second at every location.
Everybody's undertaking digital transformation, right? We've all heard it probably to ad nauseum, but we're taking it really serious. We're investing in our company and flattening the entire corporation, and taking and saying that Aero is no different than space, that is no different than RMS, that is no different than MFC. There are 4 divisions, by the way. So I can share work products across my division, enable a model-based enterprise with a full-scale digital thread and digital twin of everything I do. And guess what? I've already enabled partially my infrastructure with Bryan's stuff just to do digital twinning. You know, now we've got data analytics to go along with that digital twin that I can throw in to visualizations. Now I take it to the next step. I have that data as well. I can run analytics in my factory to say, here's an example with you earlier. In one of my factories in Camden, I have an operation that's automated, and 4 people handle this operation in one particular place. And I build 52 of these things a day, and that's as much as I'll say about that, but I could build 65 of those a day if I'm smarter about how I use the data and how I use the employee building the thing. Even though there's partial automation, you know, there are steps that are manual, so we're looking at all aspects of the data coming from the edge. The edge is telling us everything. And I've really challenged the business areas inside of Lockheed to say, how do we enable our digital thread? How do we enable our model-based enterprise? And how do we stop collecting what we don't need? If it's not a value add, and how do you identify what's value add? What reduces time? What increases profit? What increases speed to delivery? These are all the things we look at. Collecting data for data's sake is garbage. You know, and we're trying to get out of that mentality that says, I just need everything. And we proved a point over the holidays where we were able to stop through IoT data coming from the edge and analytics, stop a subassembly that can impact F-35 deliverables significantly. So, you know, we're working with Bryan's team to figure out, okay, we've made this one example. How do I scale these examples at scale, right? Scale at scale across the entire corporation. When I solve a problem for one, I solve a problem for many, and be able to drive business value down as far as production manufacturing of these highly complex, highly integrated systems. Why do you need to know what happened to it from there to there? There's a very good reason.
And of course, we're about improving yield, right? Reducing waste. And if we can identify a manufacturing problem at step 2, instead of going all the way to step 10 and back to step 2, back to step 1 to sand it back down, that's our
Vision products are performing very well, so I have a challenge: how to make more with less. I use technologies like Bryan's to enable my factories to perform at 20% above capacity, to 30% above capacity. And Bryan's team is, you know, one of the things I really like about Thinaer when we approach them is they help us think outside the box, because we take a very engineering approach to how we do things, and sometimes we can't get out of that lane. And Bryan's team has come to us with, well, I kind of agree with you, but what if we do this? And how about if we take a look at from this approach? So taking data to a service and creating that plutonium value in the data that we're gathering to deliver for our customers faster, cheaper, and then even with new products come to market twice as fast.